a great example that I always use is I occasionally, in making dummy user interfaces, want to generate random colors. The NSColor and UIColor classes by default can't generate a random color, so I've often found it useful to add a category to UIColor that adds a random method. And a great way to do this is using a category. So the way you declare these is you have an add it looks very similar to a class declaration, except that there is no parent type specified. Instead, you have the name of the class that you're extending, and then in parentheses, some name for your category to kind of make sure that the namespaces don't collide, even though that can still happen. But just kind of to mark that this is, I might have said interface, UI color, random, or something. And then the implementation file looks the same. Again, you have to indicate which category you're fulfilling by putting them in parentheses. And a common convention for naming these files is the name of the class you're extending plus the name of the category. But again, that's just convention. The other thing that categories allow us to do is to create informal protocols. I highly recommend you do not do this, but you can create a category on NSObject and just adhere to this protocol. It's a really weird way to do this. And the main reason you don't want to do this is because informal protocols don't have language support. So in particular, that means the compiler won't tell you if you haven't provided bodies for these methods, because it doesn't know, because these are just categories, and hopefully they're defined somewhere, but they might not be. But just kind of to give you some background, that's how they made protocols before they actually had protocols. Okay, I kind of went over that quickly because categories aren't used super often, but they're kind of a cool thing if you want to extend the class without actually going through all the work of subclassing. So I have one quick little thing to talk about, and that's Objective-C exceptions. So you can throw an exception using the @throw directive, which takes an exception, which is usually an Objective-C object, usually in an exception object, and you can handle exceptions using @try, @catch, and @finally blocks, very much like what you see in other languages. So I don't think I need to go over that in any great detail. But here's an example of handling a try of some. And like in other languages, you can catch multiple different kinds of exceptions in different catch blocks, but you can also have a catch-all block that just says catch and doesn't specify or it might just be able to say exception, some general exception type. Did I not have another slide about that? Okay. Anyway, there was one other thing I wanted to say about exceptions, and that unlike languages like Java, which use exceptions fairly heavily, you should not rely on exceptions in Objective-C because they are very, very, very inefficient. They really should be used only for very exceptional circumstances, which is why they're called exceptions. But some languages tend to abuse that. Python, for example, uses an exception to stop iteration, which is perhaps not the best way to do things. But that's Objective. So it's very rare that you deal with exceptions. I actually, for the longest time, didn't ever write a try catch because I just never needed it. The dynamism of Objective-C tends to kind of eliminate the need for exception handling because everything just kind of gets handled gracefully anyway, which is kind of nice. So, I know that was a lot of kind of really random topics to cover, but I kind of just wanted to give you a rounding of some of the main aspects of Objective-C programming. So do I have any other questions about what I talked about today?
And we'll practice with a lot of these things during all of these labs. Use all of these topics. So you are going to get some practice with it.
Yeah.
What is finally? I want to see try, catch, and throw in C++. Never see that.
Yeah. So finally, we'll get called the finally block will get executed regardless of whether or not an exception occurs.
Can you show the slide?
Yeah.
Finally is a way to clean up. It's a cleanup to. It's like, say, above your try, you've opened up a couple files, you've allocated some memory, then you do a try that may throw an exception or not. Regardless of whether or not you threw an exception, you want to make sure that you close the file, release the memory. All that stuff goes in the finally block. So this will always be called whether or not an exception happened. And then you can keep throwing it back up to the top. But this is usually where you have a lot of cleanup code or logging code to say, that you finished this or you skipped a step.
Okay. Does that sound good to everybody? Okay, so we have another really great lab today. I'll post it in a few minutes, and how do we want to handle in 10 minutes? Do you want to get out a piece of paper?
I'll do that.
Yeah, so come up to Glenn at some point and put your name on the piece of paper he's going to get out, just to make sure we know who's here and that we can make sure that everybody that's not actually in the class can get in. And can you make sure that there's a column for whether or not they're on the wait list?
Yep.
Okay, so I will announce when the lab is up. This should take a few